Good afternoon, everyone. Thank you, Sir Jordan, for the introduction. So, again, good afternoon, everyone. So, my name is Andrew Charles Yang, and I am representing Meralco's Embedded Generation Integration Planning. And today, I'm going to give a short talk on embedded generation integration, the Meralco experience. Okay, so here's a brief outline of my presentation. So I'll start off with the overview of the Meralco system, and then just some definitions of embedded generation and renewable energy, as well as yung particular focus of my presentation, which is variable renewable energy. And I'll also be showing some of the renewable energy solutions that are being offered in Meralco, as well as a simple flowchart of the interconnection process if you wish to apply your embedded generation with Meralco, as well as a snapshot of the embedded RE plans currently in the Meralco franchise. So as a brief overview, Meralco's franchise area covers an area of 9,685 square kilometers. It serves 7.8 million customers as of year-end of 2023. The franchise area consists of 39 cities, 72 municipalities, and covers a land area of 3% of the Philippine land area. But within this franchise area of Meralco, it houses 25% of the Philippine population. And the franchise area also caters to 50% of the GDP and contributes 55% of Philippine energy sales. Okay, so now just to describe a paradigm shift that is currently happening in the electric power distribution system. So the facilities shown in the rectangle in the middle, so these represent the facilities in Meralco's distribution system. So we have our delivery point substation, which acts as the transition point between the distribution utility and the NGCP's transmission facilities. And then we also have sub-transmission lines, which conveys power from the NGCP grid towards Meralco's distribution substations, which are located in different load centers across the franchise. And the distribution substations will now convey the power to Meralco customers through our distribution lines and distribution facilities. So in the conventional power distribution system, so bulk power is produced at our bulk generation plant. So that's the square or the rectangle on the upper right, yeah. And then it conveys the power through the transmission facilities to the different DUs covering the country and then serving our customers. So the paradigm shift in recent years is that there is an increased uptake in the integration of embedded generation, particularly VRE in the system. So embedded generations is connected to the distribution system rather than the national grid. And these are connected at either the subtransmission level, directly to distribution substations, or distribution facilities serving our customers. And there is also a subset of embedded generation, which is called net metering, which is connected behind the meter. So that is at the household level. And this has given rise to the what we call prosumers or consumers, which also produce their own power. Okay, so what is embedded generation? So per the PDC, so embedded generators are generating units that are indirectly connected to the grid. So mind you, the grid with the capital G is actually the national grid. And through the distribution utilities lines or industrial generation facilities that are synchronized with the grid. So there are two types of embedded generation. So we have conventional embedded generation and renewable embedded generation. Shown on the bottom of the screen is a simple infographic of our power distribution system. So the area in the hash rectangle is the distribution utility, and the embedded generation, as mentioned before, are ones connected to the subtransmission level, directly to the substation or the distribution facilities, as well as the house level. And these are denoted by the small generation units you see at the bottom, which are connected to the distribution grid by the red wires. So just to give a more fleshed out definition, so here is your block diagram describing our embedded generation as well as the different classifications now as viewed by Meralco. So we have conventional generation. So conventional generations are those that utilize finite fuels as their power source. So these can be coal, gas, or oil. And then we also have renewable generation. So renewable EGs are generators that utilize resources that do not have an upper limit. And these resources are renewable on a regular basis and have a replacement rate that is relatively rapid. So they are virtually unlimited in nature. So in Meralco's definition, so we have renewable EGs, but this can also be classified between non-variable and variable EGs. So the main difference between the non-variable and the variable EGs is the non-variable EGs have direct control over their output. So based on the fuel source. And variable EGs have intermittent or varying output. So I'll just give a brief explanation on the VRE. So what is VRE? So it's a generating facility consisting of one or more generating units where electricity is produced from a source that is renewable or cannot be stored unless you're using a battery or intermittent in nature. So some characteristics of the plant, of a VRE plant, is the variability of its output. So it depends. This is because generally, VRE plants are based on weather dependent on nature. So we have solar, we have wind. So it depends even if there's a clear day, it might not be sunny, it might be cloudy. So the output of a solar plant can vary even on a clear day. And then it's also location constrained or location specific because most of our VRE plants are either solar or wind or run-of-river. So particularly for the run-of-river, so you have to install your plant along the river. And then for wind plants, in order to optimize the maximum output, you have to place them in optimal wind corridors across the country. But the main advantage of VRE plants is they are modular in nature. They are comprised of a combination of a lot of small plants that are grouped together. And in this configuration, they are very scalable if you want to expand your capacity. Okay, so this is a new term that was introduced into our lexicon. The distributed energy resources. So this was brought about by the rules released by the DOE in 2022, Resolution 11, series of 2022. So distributed energy resources is a subset of VRE. So it's smaller power sources connected to the distribution system or the electric system of the end users that could be aggregated to meet a demand. So they are usually renewable energy systems. They are connected at the house level or at the business facility level. And electricity is generated or managed behind the electric meter. And most of these are, especially in the Meralco environment, are rooftop solar, energy storage or battery energy storage. And on the right, you can see some examples of DER. So we have solar, microwind, biomass, EVs, and run-of-river. So in terms of interconnection of our embedded generation, so we have two types. So as I mentioned, Meralco handles embedded generation. So embedded generation or distributed energy sources, the one in the green rectangle, are connected to the distribution system. And then we have different modes of operations for our embedded generation, which are large exporting, EGs, own use EGs, which offsets one's own consumption, and net metering, which is the mode is you offset your own consumption, but with excess power you can generate to the grid. And then we also have grid-connected generation. So grid-connected generation is connected to the transmission grid or NGCP, and then mostly consist of large generating plants, which are comprising of hundreds of megawatts of capacity. And then since they're connected to the grid, so they're managed by NGCP or the transmission system operator, and they usually supply their power to the grid level. Okay, so these are the types of RE solutions that are present in Meralco right now. So we have they are dependent on the plant's capacity, the point of common coupling or the connection point, as well as the mode of operation. So here is a slight infographic. Later, I'll have a more detailed table to describe yung different solutions. So I'll start off at the bottom, which is net metering. So as I said before, net metering is a solution that is connected behind the meter. So the main objective of this solution is to offset one's own consumption as well as to sell off your excess power to the grid if there's any excess power. So they are connected at low voltage distribution system typically, and they range from 100 kilowatts and below. Then we have exporting DER or exporting distributed energy resources. So in interpretation of the rules set out by the DOE, it's like a expansion or a extension of the net metering program. Whereas the net metering program limits ourselves to capacities below 100 kilowatts. For the exporting DER, it's now from above 100 kilowatts to 1 megawatt. So the mode of operation is the same, offsetting one's own capacity as well as selling off the excess to the grid. And then we also have zero export or own use, DER. So the objective of these is to offset one's own capacity, but will no longer be exporting their power to the grid. And then lastly, we have the large exporting embedded generators. No? So these can be connected to either the distribution level or the subtransmission level. And in Meralco's current environment, they range between 100 kilowatt all the way up to a maximum of around 75. Okay, so here's a brief summary of Meralco's RE solution. So as mentioned before, we have net metering and its partner exporting DER. No? So as mentioned, they are both operating on the principle that you can offset your own consumption. And if you have any excess consumption, you can sell it off to the grid. So for net metering, the RE capacity is 100 kilowatts and below. And then for exporting DER, it's above 100 up to a maximum of 1 megawatt. Another main difference between the two, so is the ownership of the RE facility. No? So for the net metering, the person who owns the house is usually the person who also owns the RE facility. While for exporting DER, it can be owned by the house owner or it can be owned by a solar installer and operator. For pricing methodology, this is particularly for the exported energy. So for net metering, 100% of your exported energy, if any, is compensable or compensated. And for exporting DER, up to a maximum of 30% of your installed capacity will be compensated. And then in Meralco's case, both net metering and exporting DER are 100% RE. And as per rules, both for net metering and DER, a RE certificate meter is required to be installed at the facility to measure the output of the VRE solution. And then they also have something called the Certificate of Compliance, which is a certificate that is being applied with the ERC. So in order to certify that your plant is already ready for commercial operations and to sell your power to the grid. So in the case of net metering and exporting DER, the validity of this certificate of compliance, which is applied with the ERC, is coterminous with either your net metering agreement or DER agreement, whichever applies. And then for zero export or self-generation facility, so these are the solutions that do not offset your own consumption but do not export to the grid directly. So, magka-partner is zero export as well as non-exporting DER. So, the main requirement for a non-exporting DER or a zero export facility is that your plant capacity should be below the contracted capacity of your load, just to ensure that there is no excess power being generated into the grid. So everything must be consumed by your own facility. And the main difference between a zero export and non-exporting DER is the second row. So in zero export, the end user is the owner of the facility. So the house owner is also the owner of the solar. For non-exporting DER, it is a requirement that the house owner and the owner of the RE facility are different. Okay? And since they are not exporting to the grid, so our installation of the REC meter is either not required or optional as per our clarification with DRC. And then lastly, we have our large embedded generation. So these are the purely exporting plants. So they can be generally any capacity, but as mentioned before, in the Meralco environment, they are above 100 kilowatts in size. No? And then the RE ownership is owned by the generation company. And then for pricing, actually, there are 4 modes of, or 4 ways where you could sell your power off. No? So there's one is the competitive selection process contract, or what we call PSA, or power supply agreement. The next is you can sell your power to WESM, directly to WESM. And then the third one is you could apply for a FIT rate, or what is currently being implemented is the Green Energy Auction Program. So this is like a fixed rate. So you don't have to be dependent on market forces if you just sell directly to WESM. And the last option is if you have an off-taker or a RES, which will buy your power, your renewable power, in order to sell it off to their portfolio of consumers. Okay? So for embedded generations, it can be RE or non-RE because we've also had diesel embedded generation in Meralco. And then for installation of REC meter, so it's a must. So Meralco and NGCP will both install a REC meter po, at your facility. However, it is NGCP's meter which is being monitored by IMAP, since they are the metering service provider of IMAP. And then for all 3, zero export, non-exporting DER, as well as embedded generations, the COC validity will be perpetual once given until any material change in your facility is effected. If you upgrade your facility, or if you change your generators, or you change your inverters. Okay, I have two more slides, so I'll just make it quick na lang po. So here's a simplified process flow of interconnection. If you plan to interconnect your embedded generation facility with Meralco. So we start off with the application. As mentioned by Sir Luigi, I think, that you have to have a service contract with the DOE in order to supply power, no? For your supply power. So if you already have that contract, you can already apply with either the grid or either the DU. If you're going to apply with Meralco, so the customer applicant has to supply all the necessary documentary requirements, as well as accomplish a plant parameter form. And the plant parameters that you submit will be used in our evaluation using our distribution impact study to ensure that your interconnection will not have any adverse effect to the system, as well as a distribution asset study if the interconnection will require the installation of any facilities or extension of facilities by Meralco. And then the primary stipulation before you can implement your project is that you accept the results of the DIS and the DAS, and that you will uphold to comply with all the requirements of the DIS and the DAS. So after the completion of your project, so we move on to step 3. No? Assuming that you already completed your project, it will be subjected to inspection by Meralco, just to ensure that you have complied with all the DIS and DAS requirements. And once complied with, we will go on to do functionality testing to energize your embedded generation, and then move on to a commissioning test, which is required to establish the generator unit capabilities, which will go into the certification that will be used to apply for your certificate of compliance with the ERC. So all the tests, functionality testing and commissioning tests, will be witnessed by Meralco and be performed by the plant. And lastly, for the final energization, so these are more on the documentary requirements, the contracts, as well as the provision of the DU certificate on the generator unit capability, so that you can begin with the parallel operation of your generation facility. So I will be ending my presentation with a brief snapshot of the current embedded generation integration in the Meralco franchise. So as of now, this is as of end of June, we already have around 530 megawatts installed in Meralco. The bulk of it is exporting embedded generation, which comprises around 315 megawatts of power. And then we also have around 130 megawatts of zero export capacity, as well as 85 megawatts of net metering customers. And in the next 5 years, based on current application timelines, we expect to install a total of about 1.5 gigawatts in the next 5 years. So actually, this is my last time. Pasensya na po over time. But I thank you for your time and attention. Thank you.
Thank you very much, Toy. Any questions from the floor? This is our last presentation. You're already having your snacks, so we'll keep it this way. Pwede tayo magtanong kay Andrew. Let's carry on the discussion. Anybody on the floor? Sige, habang nag-iisip sila, Doy, may tanong ako.
Yes, sir.
Kita na ng Meralco yung duck curve.
Yes, sir.
How bad? Sige nga.
Well, in the case of Meralco kasi, sir, malaki po yung demand namin due to scale. So, hindi pa siya ganun kalala. Like, for example, in other jurisdictions, like, for example, sa Australia, where they're already ordering the shutting off of some solar due to overgeneration. So, yun pa.
Projection, how soon will this be an issue?
Well, actually, right now we are being mandated to give a report monthly to the ERC if there are any reductions or significant reductions in our power purchases. But so far, sir, malaya pa ho talaga.
Thank you. Anybody? Anyone else? Sige, si Leo yata to. Sige po. Ano to?
Hi, sir. Good afternoon. Leo po from the UP EEI. Sir, regarding perhaps the policies of Meralco when it comes to net metering, kasi before we were told that when you will be admitted to the net metering program, as long as you don't have the battery storage for your system, do you have updated policies regarding this, especially for rooftop solar, perhaps residential or office spaces that have battery storage together with solar?
Yeah. Thank you for the question, sir. No? Actually, right now, the Meralco is currently reviewing current policies with regards to integrated solar and in BESS. So as of the moment, the status quo of the policy remains. So it should be a separate BESS muna. So yun pa. Thank you.
Thank you, sir.
Anyone else? Ako may tanong pa, Doy. Yung second to the last slide, you talked about 1.5 gigawatts in the future.
Yes, sir.
Tama.
That's based on, Bali, that's based on our current application timeline. So, pipeline, sorry. Application pipeline.
Hindi ko alam kung secret pa yun, ano. Pero may 2 gigawatts daw na binabantayan sa Laguna Lake. Totoo yan?
Actually, yes, sir, tama. That's true. Actually, we were also tasked by DOE to take a look into dun sa mga applications, Laguna Lake, floating solar. However, yun nga, under Meralco's jurisdiction, yung nag-apply po sa Meralco. So, most of them did not fall into the pre-approved areas of the Laguna Lake LLDA. So, yung current application pipeline namin did not fall into that. So, it's a different set po that is being implemented right now.
So on top of that?
Yes. Apa.
Thank you, Andrew. Anybody else? Anyone else? Sige. So we give the certificate of appreciation to Andrew. Sige. Certificate of appreciation is presented to Andrew Charles Yang for sharing his presentation on the Meralco experience on embedded generation integration, NEECECON 2024, signed by Dr. Lou Tria, Director of EEI. So that ends our session for this afternoon. Sorry, for this first set of presentation. You should be having your snacks by now. We'll carry on with the second set of presentations. That will be technical panel session 4, which will be chaired by Sir Ramon Santos over there. But I hope you appreciate the discussions this afternoon. We started with the future of energy transmission by Sir Ton Ambatali. And then we had a big discussion on generation and transmission planning, but we capped it off with what's happening closer to us with embedded generation. So all of these are contributing to the national development through sustainable industrialization, which is the theme for this conference. So again, thank you very much for joining us this afternoon. And enjoy the rest of the meeting. So I was reminded the next session will start at 3:10, okay? So, but before we leave this room, we once again extend our heartfelt gratitude to Advanced Energy, Techmark Keysight Technologies, Embedded Silicon Technology Solutions Corporation, Meralco, Analog Devices Incorporated, Presidium.ph Corporation, Rhodes Quartz Philippines, Alexan Commercial, Maker Lab, Samsung Electronics Philippines Corporations, and Challenge Systems for their invaluable support to NEECECON 2024. The next set of presentations for TP4, which will start at 3:10, are even more exciting, so we hope that you will come back after the break. Thank you.